Assalamualaikum warahmatullahi wabarakatuh. So, our group number 6 will be present about crude oil distillation. For our team member, Muhammad Afiq Aiman bin Jamaluddin, Muhammad NAZMI ZUHAILI bin IBRAHIM, Wan Ahmad IRFAN bin Wan ISMAIL, Muhammad Hafiz ADLI bin Muhammad YASIN, and Muhammad HAFIZUDDin bin ALIAS.
My name is Muhammad Afiq Aiman bin Jamaluddin. I'm going to discuss about industry background. So what is a crude oil? Crude oil is a petroleum product made up of hydrocarbon deposits and other organic elements that occur spontaneously. Crude oil is a type of fossil fuel that is refined into usable products such as naphtha, gasoline, diesel, and a variety of other petrochemicals. It is a finite resource since it is a non-renewable resource that cannot be replaced naturally at the rate at which humans utilize it. That is a crude oil background. The successful drilling of the first oil wells in Ontario, Canada in 1858 and Titusville, Pennsylvania in 1859 gave rise to crude petroleum refining. Simple distillation units or stills were used in the early refineries to separate the various constituents of petroleum by heating the crude oil mixture in a vessel and condensing the resulting vapors into liquid fraction. The still's lowest boiling raw product was straight-run naphtha, a precursor to unfinished gasoline, which is petrol. Its initial commercial application was as a solvent at first.
Okay, thank you to Afiq Aiman for the presentation. So my name is Muhammad ZUHAILI bin IBRAHIM. So I will continue the presentation from Afiq Aiman. First one, type of crude oil. So we have 4 class here, which is class A, class B, class C, and class D. So the first class A, which is light volatile oil. So the characteristic of this oil is highly fluid, often clear, spread rapidly on solid and water surface. It has a strong odor, highly evaporation rate, and mostly of them is flammable. For class B, which is non-sticky oil, the characteristic is waxy or oily feel, less toxic but more firmly than class A. It can be removed by vigorous flushing, can be persistent at high temperature, and medium to heavy paraffin based oil mostly fall into this class. The third class is class C for heavy sticky oil. Number one, most of them high in viscosity. Next, they are sticky and terry. Number 3, brown or black in color. 4, cannot be removed by water flushing and not readily penetrate porous surface. Next, the density is near to water and often sink. Lastly, toxicity is low, but wildlife can be drawn when contaminated. The last class, which is class D, non-fluid oil. Characteristic is relatively non-toxic, do not penetrate porous substrate, usually black or dark brown. They are water temperature greatly influence the behavior of oil. And lastly, refined petroleum product in environment. For industrial background, which is naphtha, we choose one of the product of crude oil, naphtha. So the function of naphtha is one of product produced from crude oil refinery is naphtha. Naphtha is a term used to refer to a group of volatile flammable mixture of liquid hydrocarbon that are used mainly as solvent, diluent, or raw material for gasoline conversion. It is used in hydrocarbon cracking, laundry soap, and cleaning fluid. Naphtha is also used to make varnishes and sometimes is used as a fuel for camp stove and as a solvent or diluent for paint. So that's all for me. I will pass to Irfan. Thank you.
Thank you for Nazmi. Next, Muhammad Hafiz Adli bin Muhammad Yasin, will present about the crude oil distillation PNID. Okay, for the PNID, the crude oil pass through pump and then desalted. After the crude oil desalted, it will go to through furnace and go to distillation column. Okay, through the distillation column, it will divide by, it will make a residuum, heavy gas oil, like gas oil, kerosene, heavy naphtha, and it also produce a gas such as butane and lighter, or gasoline. The gas will through the gas separator, which is separate the gas and gasoline. Okay, for the stage of oil refining, there are three stage, which is separation, conversion, and treating. Okay, for the first is separation. The first stage of refining since molecule separate according to the weight using a process known as atmospheric distillation. It starts with the oil being heated at temperature of up to 400 degrees Celsius in a 90-meter deep distillation column. This causes the oil to vaporize and ascend to the top of the column. Meanwhile, the heaviest molecule, also as the residual, remain at the bottom of the column. This is include the highly viscous material such as asphalt. For the second stage is conversion. After the separation process, oil then undergoes conversion to remove heavy hydrocarbon molecules and create lighter product. To do this, the heavy molecules are heated to temperature of 500 degrees Celsius and cracked into lighter molecules with a catalyst used to accelerate the chemical reaction. Roughly 75% of the heavy product are converted into the gas, gasoline, and diesel. Okay, for the last stage, which is treating. During the treating stage, oil undergoes process designed to remove corrosive and polluting molecules, include sulfur. Caustic soda wash is used to sweeten kerosene, butane, and propane, and remove theosis. Automatic fuel are treated with catalyst to convert naphthenic hydrocarbon into aromatic hydrocarbon and increase acetone rating. After undergoing the three stage of refining, crude oil is ready to be resolved as a refined petroleum product include LPG, gasoline, naphtha, and lubricant. That's all from me. I will pass to the next presenter.
Thank you, HAFIZUDDIN. So for the concept and process of crude oil, firstly, fractional distillation. This process is based on the principle that different substance boil at different temperature. For example, crude oil contain kerosene and naphtha, which are useful fraction. Naphtha is made into petrol for car, and kerosene is made into jet fuel. When evaporate the mixture of the kerosene and naphtha, and then cool it, the kerosene condense at a higher temperature than the naphtha. Crude oil refinery process. It starts with a fractional distillation column. The various components of crude oil have different size, weight, and boiling temperature. So the first step is to separate these components because they have different boiling temperature. They can be separated easily by a process called fractional distillation. After going through the fractional distillation, crude oil is chemically processed to change one fraction into another. Finally, distilled and chemically processed fraction are treated to remove impurities. Okay, for the naphtha process, firstly, name of the component is naphtha, state of matter, gas, liquid, number of carbon mix of 5 to 9 carbon atom alkane. Boiling range 35 to 210 degrees Celsius, which is divided by 2, which is heavy naphtha and light naphtha. Uses of naphtha is made varnish as a fuel for camp stove and as a solvent diluent for paint. Shale naphtha is obtained by the distillation of oil produced from bituminous shale by destructive distillation. Petroleum naphtha is a name used primarily in the United States For petroleum distillate contain principally aliphatic hydrocarbon and boiling higher than gasoline and lower than kerosene. Next, this is the process of naphtha. Heating the mixture of the substance of crude oil, which is liquid with different point to a high temperature. Heating is usually done with high pressure steam to temperature of about 600 degrees Celsius. The mixture boil, forming vapor. Most substance go into the vapor phase. The third step is the vapor enter the bottom of a long column, which is fractional distillation column. That is filled with tray or plate. The tray have many hole or bubble cap in them to allow the vapor to pass through. It is increase the contact time between the vapor and the liquid in the column and help to collect liquid that form at various height in the column. There is a temperature difference across column, which is hot at bottom and cool at the top. Next, the vapor rise in the column. As the vapor rise through the tray in the column, it's cool. When a substance in the vapor reach a height where the temperature of the column is equal to the substance boiling point, it will condense form to a liquid. The tray collect the various liquid fraction. And lastly, the collected liquid fraction may pass to condenser which cool them further and then go to storage tank, or they may go to other areas for further chemical processing. So I will pass to the next presenter.
So for the last, I, Muhammad HAFIZUDDIN alias, I will present about comparing between distillation process, gas absorption, and liquid-liquid extraction. So we compare based on the definition, method, and the process required. So for the definition of distillation, so distillation is separation by mass transfer process in which the component of the feed stream are separate based on their distribution between the vapor and liquid phase by thermal means. For the gas absorption, mass transfer operation in which one or more species is removed from gaseous stream by dissolution in a liquid. So for the liquid-liquid extraction, the transfer of solid of a liquid solution, diluent or carrier by contact with another insoluble liquid which is solvent. So for the method used in the distillation process, a method is based on the simple distillation, which is frequently used in the laboratory or industry, which is involve the production of vapor by boiling the liquid mixture to be separate in a single stage. For the gas absorption, a method based on absorption of a gaseous compound that can undergo chemical reaction in liquid solution. For the liquid-liquid extraction, a method to separate compound or metal complex based on their relative solubilities. And for the process required in the distillation, it requires heating and the cooling. At the gas absorption, it's same. It requires heating and cooling. But in the liquid-liquid extraction, it doesn't not require heating and cooling process. So that's all from our team. Thank you.